Hi, today we are going to discuss how to sketch this function f of x equals to x to the power of 4 minus 4x cubed by using the first and second derivative test. Let's get started. The main idea is the first step we have to find the x and y intercept of this function. Then only after that we find the first and second derivatives. So let's get started. How to find x-intercepts? We can get the x-intercept when we take the value of y equals to 0. So we plug in y equals 0 equals to x to the power of 4 minus 4x cubed. Then from these two terms, we factorize the x cubed because both has the common factor of x cubed. Then x to the power of 4 taken out the factor of x cubed, we have x left. And minus 4x cubed taken out the factor of x cubed, we will get minus 4 only. How to obtain 0 in here is either x cubed equals 0 or x minus 4 equals 0. If x cubed equals 0, then x equals 0. If x minus 4 equals 0, then x equals to 4. Now our x-intercept is x equals 0 and x equals 4. This is where the graph will cut the x-axis at x equals 0 and x equals 4. After x-intercept, we want to find the y-intercept. How do we find y-intercept? When we take x equals 0. So we substitute x equals 0 here and 0 here. 0 minus 4 times 0 is 0. So it's the same coordinates 0, 0. So this is also y-intercept and also x-intercept. In the first step, we got the x-intercept 0, 0 and 4, 0. And the second step for y-intercept, we'll get y-intercept is 0 and it is 0, 0. So it's the same coordinate for x-intercept and y-intercept. This is where the graph cut the y-axis. And for this function, there is no vertical or horizontal asymptotes as this is a polynomial. And the domain, it means all possible value of x is from negative infinity to positive infinity. And so also the range is from negative infinity to positive infinity. There is no limit. Now let's get to the next step number 3, which is first to find the first derivative, and step number 4 is to find the second derivative. This is the step to find first derivative, f of x equals to x to the power of 4 minus 4x cubed. Now the first derivative is f prime equals to x4 become 4, we put down 4x cubed, 4 minus 1 is 3. Now 3 we put down times minus 4 become minus 12 and the x cubed become x squared. We subtract 1. 3 minus 1 is 2. Now we can factorize these two terms which has the common factor of 4x squared. Now 4x cubed, we take out the factor of 4x squared, then we will have x left. Minus 12x squared, taken out the factor of 4x squared, and we have minus 3. So minus 12x squared divided by 4x squared, we have minus 3. So this is factorized, the first derivative. Now we want to put the first derivative equals 0 because this is the stationary value, stationary point. And when this is equals 0, it will happen when 4x squared equals 0 or x minus 3 equals 0. For 4x squared equals 0, it means x squared equals 0 and x equals to 0. For x minus 3 equals 0, it means x equals to 3. Now let's catch them on the number line and we will do the first derivative test. We put x equals 0 here and x equals 3. X equals 0 on the number line and x equals to 3. So here we go. We put them on the number lines. Then we have 3 segments before x equals 0, between x equals 0 and x equals 3, and greater than x equals 3. Let's do the test. How do we do the test? By take a number before x equals 0. The easier number is minus 1 because it's easy to count. Let's plug minus 1 into the equation. If we plug minus 1, it means 4 times minus 1 cubed and minus 12 minus 1 square, we will have this section is negative because minus 1 cube is negative. So this section will become negative. And this section minus 1 square is positive. Positive times minus 12, it means this section also become minus. So the answer will give us minus result. So this is minus result. Or we can test it to the factorized form, which is in here. So we can test the sign using the factorized form in here. Let's copy this. If we plug minus 1 in here, minus 1 square will give us positive. So this side will be positive. 4 times 1 will be positive. If we plug minus 1 in here, minus 1 minus 3 is minus 4. So this also will be negative. So positive times negative will get the result is negative. So this side will be all negative for x smaller than 0. Now let's test the second segment, which is between 0 and between 3. We pick a number that is, we take 1 because 1 is between 0 and 3. Now let's plug 1 into the x. 1 and 1 here. If we put 1 square is positive times 4 is positive, so this segment is positive. 1 minus 3, 1 minus 3 is negative because negative 2, so positive times negative is negative, so this segment will be negative also. Now the third segment is x greater than 3. Let's check it out. For x greater than 3, you plug in this one 3 in the equation. We can take 4 because greater than 3 we can take 4. Let's take 4 in here. So 4 squared is positive times 4 is positive, so this is positive. 4 minus 3 is 1, 1 is positive, positive times positive is positive, so this segment will be positive. That is how we test the first derivative. Now we get this minus minus positive. Now we know for first derivative, when there's a change from negative and then positive, and this point we call as the minimum point. So this point is equals to minimum point, x equals to 3. Now let's plug in 3 into the original equation, which is f of x equals to x to the power 4 minus 4x cubed. So we plug in x equals 3 to the original equation, x to the power 4 minus 4x cubed. If we substitute x with 3, then we will get 3. Because 3 is the minimum point, then we will get y equals to negative 27. So if we count with calculator, 3 to the power 4 minus 4 times 3 cubed, we'll get negative 27 as the minimum value of this graph. Now let's see the second derivative. This is the parent function and this is the first derivative, and we want to find the second derivative. f of second derivative. So f prime prime 12x squared minus 24x. 3 times 4 is 12. 3 minus 1 is 2, so 12x squared. 2 times 12, the 2 we put down, times 12 minus 24, and x squared. 2 minus 1 is x only. So this is our second derivative equation. Now we have to make the second derivative equals to 0, so we can test the second derivative. When it is equal to 0, so first we factorize 12x squared minus 24x. We take out the common factor, that is 12x. So 12x squared taken out, 12x is x. Minus 24x, we take out the factor of 12x, we'll get minus 2, because minus 24x divided by 12x is minus 2. If 12x equals 0, so 12x equals 0, x equals to 0. So the equation will be equals to 0. Or this side equals 0, because anything sign this 0 will also become 0 for f of second derivative. If x minus 2 equals to 0, then x minus 2 equals 0 and x equals to 2. Now let's put them in the number line. So x equals to 0 and x equals to 2. So this is x equals to 0 and x equals to 2 in the number line. Now we have three segments. The first segment is the value of x smaller than 0. The second one is the value of x between 0 and 2. The third one is the value of x greater than 2. Now let's take the number before 0. We take -1, which is all the easy number. Between 0 and 2, we take 1. Greater than 2, we take 3. So this 3 number we want to plug into the second derivative to test for the sign. Now let's check this out. So we can test using this factorized form, which is this one. Let me copy this one. So when we plug in x equals to -1, we put in here 12 times -1. We will get this segment minus, because 12 times -1 is -12, so it's minus. And when we plug in -1 to here, if this is -1 in here, -1 times -1 -2, -1 subtracted by 2, -1 -2 is -3, so this is minus. So minus times minus, minus times minus will give us positive. That's why we put this sign positive. Now for the value of x between 0 and 2, we take 1. Now we plug in 1 here. Positive 1. Now if we put 1 here, 12 times 1 is 12 positive, so this is positive. Now for this segment, 1 minus 2 is negative, 1 minus 2 is -1, so it's negative. Positive times negative will give us negative. So this section is negative. Now for the value of x greater than 2, we take 3 here. Let's test them in the second derivative. So we take 3, we plug in 3 here. So 12 times 3 is 36, so it's positive. 3 minus 2 is 1, so it's positive. Positive times positive is positive, so this section is positive. So we are done with the second derivative test. Now we have this is the change from positive to negative. This is what we call as inflection point for second derivative test. This is negative to positive. So what does it mean by that? When it is positive, the curve is facing up. So we do like this. When it's negative, the curve is facing down like this. and this is positive again, the curve should face up. So there is a change from here, curve face upwards and downwards. So this is what we call as point of inflection in x equals 0. And also there is change from here, curve face down and then continue by curve face up. That is the value of x equals to 2. So this is another point of inflection. Then we summarize this. For x smaller than 0 and x greater than 2, it is positive here. It is positive. So we summarize this. For x smaller than 0 and x greater than 2, the function is concave up. And for x between 0 to 2, the function is concave down. With the point of inflection is x equals 0 and x equals to 2. When x equals to 2, we plug in into the parent equation. This is our parent equation. So when we plug in this equals to 2 here, 2 to the power of 4 minus 4 times 2 to the power of 3. Then when we count, we will get negative 16. This equals to negative 16. So we'll get negative 16. So the coordinates on the parent graph will be 2, negative 16. And for the x equals 0, of course, it will be 0, 0, which is the x and y intercept in this question. So we have another coordinate, which is the inflection point for this one. So here we go. We are done with our 4 steps. Then we want to summarize all our information. So this is our result for the second derivative test, this one, and this is the result for first derivative test. This is the minimum value, minus 3, negative 27. We will have these coordinates in our graph, minimum value. And this is point of inflection. So this is point of inflection. This is our minimum value from the first derivative test. And we sum up like this. From the second derivative test, when x smaller than 0 and x greater than 2, this area and this area, the function is concave up. And when x is from 0 to 2, the function is concave down with a point of inflection 0, 0 and 2, negative 16. From the first derivative test, we have for the value of x smaller than 0 and x between 0 and 3 here, the sign is negative. It means then the slope of the function is negative. And for x greater than 3, the sign of the first derivative test is positive. It means the slope of the function is positive, is increasing. The function is decreasing for this one, and for this one, the function is increasing. And we also have the information of the x-intercept is x equals to 0 and x equals to 4. So we have this coordinate 0, 0, and 4, 0 in the graph. So this is the same 0, 0, the same coordinate. So now we have first coordinate. First coordinate is 0, 0. Second coordinate is 4, 0. Third coordinate is 2, negative 16. Fourth coordinate is 3, negative 27 as the minimum value. So we have 4 coordinate to plug. 0, 0, 4, 0 here. So 4 0 0 0. I shade this with yellow. Now we have 3 comma negative 27 as the minimum value, so I plug in this one 3 comma negative 27 here, minimum value. And we have the fourth coordinate is inflection point of 2 comma negative 16, 2 comma negative 16. We plot in here 2 comma negative 16. This is our coordinate 2 comma negative, so we have 4 coordinate plot on the graph. Now let's check from the first derivative signs and second derivative signs. From the first derivative, it says that for x smaller than 0 and x range from 0 to 3, the graph is declining. So we have to put the graph is declining like this until 3. Then after that, the graph is increasing. The graph is increasing. This one, the graph is increasing x greater than 3. So our graph is here. This is 3. So before 3, the graph is declining. It's going down. This is 3. So before 3 is going down like this. Then after 3, so if I make a line within 3, before 3, the graph should decline down like this. It should go down. And after 3, it should go up. After 3 should go up like this. So according to the first derivative test, before 3 should going down the graph, and after 3 should go up. So this is the rough sketch of our graph. Now let's see the second derivative test. Now I erase the line in 3. Now I put the line at 2, because according to the second derivative test, x smaller than 0 and x greater than 2, the graph is concave up, and between 0 and 2, the graph is concave down. Here I put the line when x equals to 2 and x equals to 0. Now we can mark where is concave up and concave down. So for x less than 0 is concave up, for x greater than 2 is concave up, and for x between 0 and 2 is concave down. Also from the second derivative test, we have 0 0 also as the point of inflection. We have 2 point of inflection. So there we go, we have 2 point of inflection at 0 and at 2. Now here we have two graphs. This is concave down and this is declining, and this is point of inflection. So we have to do like this, and this is still concave. Now after past this line, it should be concave down, but it's still, the graph is still declining, so it should be like this, going here. Now we reach the second point of inflection. This is equals to x equals to 2. Since this is the point of inflection, x equals to 2, so this should also, this is concave, and after x greater than 2 is concave up, so this should be concave up. The function is still declining down there until the minimum value of x equals to 3 here. This is x equals to 3, so we have to pull this function down until we reach x equals to 3, which is the minimum value. Then after that, it will go up with concave up. So we still have to decline, and it should be concave up. So this is point of inflection, so we make this concave up, something like this, and it bounds at the minimum value of x equals to 3. Then it will go up this graph. We just continue this, it bounds going up here and has to reach all the way to x equals to 3. I mean x equals to 4, because our intercept is 4 comma 0, so we have to go up all the way and pass to 4 comma 0. Now I erase the helping line. So this is our graph. So it passed through our 4 coordinates 0 0 2 comma negative 16, 2 comma negative 16. This is 2 comma negative 16. This one, 2 comma negative 16, and minimum value of 3 comma negative 27, 3 comma negative 27, and it passed to the another x-intercept is 4 comma 0 from here, 4 comma 0, and it declined with the value of x before 3 is declining, going down, and after 3 is going up, with the concave up is before 2 up, and concave down is between 0 and 2, concave down, and then after 2 it will be concave up again. So this is concave up, and this is also concave up. So this is our graph, and we erase the helping curve. Yeah, so that's it for today. If there's any question, please feel free to write down in the comment section. We'll explain to you with another video. Bye, and see you in the next video.